So I'm going to show you the integration technique that we call U-subs. So we're going to use substitution to find antiderivatives. So this first part, this is kind of like another desensitization lesson. So we're going to let U equal g of x, where g prime of x is continuous over a given interval. And then we're going to let little f of x be continuous over the corresponding range of g. And we're going to let capital F of x be the antiderivative of little f of x. So just like fundamental theorem of calculus. So capital F is our antiderivative of little f. Okay, so then the integral of f of g of x times g prime of x dx, we can transform into the integral of f of u du, right? So we let u be g of x, so f of g of x, here's your u. And then g prime of x dx, that's du, right? So it's just rewriting it. And then finally, here's the part we're getting to. That means we get to capital F of u, so the antiderivative of little f of u, but u was g of x, and then always write plus c. Okay, so you can think of this, it's the undoing of the chain rule, right? Because think about, right, if we had capital F of g of f of x plus c, and we had to do the derivative, right? We do the derivative of the outside function, f capital F prime, evaluated at the inside, times the derivative of what's inside. And then the derivative of c is 0. Okay, right, going back, right, what we had. Okay, so typically, right, when we do these, when we're doing U subs, it's because that inside function is not just x. Okay. And again, typically, not always, but let's say 90% of the time when you go to do your U sub, we're going to let u be that inside function, right? U equals g of x. G of x is that inside function. So here's our first example. We're going to find the antiderivative of, so the integral of 4x squared plus 9 all raised to the 7th power times 8x dx. Now, right, an option is we could use binomial expansion theorem and write this all out, right? We could find 4x squared plus 9 to the 7th power, write it all out, multiply through the 8x and integrate term by term. But look how easy it's going to be doing it the other way. So the inside function, so we're going to let u equal 4x squared plus 9. Okay. So once you have u, then you do du dx. So we take the derivative of u with respect to x, and what do we get? So 8x to the first, derivative of 9 is 0. Okay. So then du, I'm going to multiply the dx over, is 8x dx. Okay. Now, look back up at your original integral, and we're going to write it in terms of u. So 4x squared plus 9 to the 7th, so that's u to the 7th. And then 8x dx, that's the same thing as du. Okay, so using the power rule to find the antiderivative, so we'll get u to the 8th over 8, right, plus c, and then back to x's. So u is equal to 4x squared plus 9. All of that is over 8. Oh, that's raised to the 8th. Thank you. And then plus c. Okay, that's a U sub. Now, if you don't have exactly du on the outside, we can, quote unquote, fix it as with constant multiples. And the thing we have to be careful of is that we're going to balance out in front. Okay, so we're going to be multiplying this expression, right, our integrand, by 1. We're just going to be super clever about how we write 1. So integrate square root of 4x plus 2 dx. So this inside function is more than just x, so that means we have to do a u sub. Again, we let u be that inside function. So in this case, right, u would be 4x plus 2. So then du dx, and usually I don't write it du dx, I do that all as one step. Okay, so du dx is 4, so that du is 4 dx. Okay, so now look up here. I don't have the 4, right? But 4, it doesn't have an x in it, and that's key. You can only do this with a constant. Okay, so if you're off by a constant, that you can fix. If you're off by something else, then we're going to have to find a different technique. Okay, but this is just a 4 that I'm off by, so that I can fix. So I'm going to rewrite this, and I'm going to keep it in x's for now just to show you. So I have 4x plus 2 dx. I'm looking around for a different color. Oh, I've got a green. Okay, so what we're going to do is we can go ahead and multiply in the 4 so that I have du there, but I have to balance it with a 1/4. And because, right, with integrals, right, the constant multiple, it can be inside, it can be outside. You can move that across. So 4 on the inside, 1/4 on the outside. Now I have, right, 1/4. I'm going to use integral u to the 1/2, and there's your du. Okay, so that's how we kind of, we quote unquote fix it so that we can do the integral. Here we go then, power rule. 1/4 u to the 3/2. Remember how I do this? Divided by 3 goes on the bottom. The 2 ends up popping up top, multiplying. I'm not going to put the plus c until I'm finished. Again, back up here. Go ahead and reduce. So what do I have? A 1/6 on the bottom. And then u. Now I'm going to go to x's. U is the same thing as 4x plus 2 to the 3/2 plus c. Okay, so then here's 4 to practice with. Here we go. So think about, remember, who's on the inside, and then what are you going to let u stand for? Okay, so if you want to pause and try these and then come back. So we're integrating sine of 7x dx. So the inside function is more than just x. So we let u be what's inside. So u is 7x. So du is 7dx. So I don't have the 7 on the outside. Remember, you can't just pull that 7 from the argument of a trig function. If you mess with the argument of a trig function, you're going to know. You're going to look up some sort of trig identity somewhere. It's not just oh yeah, that's what that was. Okay. So, but I can put a 7 on the outside. So I'll put a 7 here and a 1/7 out front to balance. So now I have 1/7 times the integral of sine u du. And, right, remember our strategy for sines and cosines. Going down its derivatives, going up its integrals. So the integral of sine wraps around is negative cosine. So I have negative 1/7 cosine u. Back to x's. Negative 1/7 cosine 7x. Plus c. Okay. What's our next one here? So I have the integral of x times secant of x squared times tangent of x squared dx. So, right, it's like, oh my gosh, there's so much going on there. And like, what should we let u equal? Well, right, you see this little x hanging out in front. Okay, so when you say, oh, well, that's the derivative, or that's kind of related to the derivative of x squared, so should I let u equal x squared? Is that helpful to me? So if u is x squared, and sometimes you're going to try, and maybe you'll have to try more than one thing, right? So we might try this first, and if it doesn't work, we might try something else. It does work. So if u is x squared, then du is 2x dx. Right, so as long as I have that extra x, I'm good. If I didn't have the x there, then I would have to come up with some other plan. But I do have the x. I don't have the 2. I can do the constant part. So a 2 for that. A 1/2 out in front. Switch to u's. So 1/2 integral. So now I have secant u, tangent u, and then the 2x dx, that is equal to du. So there's du. Right? So then, what's the antiderivative of secant u tangent u? Du. Right? So 1/2 secant u back to x's 1/2 secant x squared plus c. How could we check? How could we check to see if we did it right? Yeah, exactly. We could differentiate this, right? We found the antiderivative. We could take its derivative. It should get us back to our integrand, right? Okay, here we go. Integral of sine t over cosine to the fourth t dt. Yikes. Yikes, yikes, yikes. What should we let u equal? Keeping in mind, we need to see du out there, right? We need to have du be there. So we need to choose u to be something that you have the derivative of. Okay, so look at this. If I let u equal cosine t, right? And if you're tempted, it's like, well, why didn't you make it cosine to the fourth t? Because wouldn't that have been better? Okay, so right, let's just say we thought that, right? If we tried to let u equal cosine to the fourth t, right, just as an option, right? And you're going to do this. You're going to choose some things that aren't right the first time, but it'll become obvious like, oh, well, that didn't help me. So you go back and you try something else, right? So if we let u try to be this, and look at what du is. I have to take the derivative of this with respect to t, right? So the 4 comes down, cosine to the third t times, right, the derivative of what's inside. So there's the chain rule. So then I have negative sine t dt. I would need to have all of that, or, right, without possibly the 4, in order to find my du there. I don't have that. I don't have and it has to be on the top, right? So I've got the sine t, that's okay. But I don't have a cosine cubed up top. And, right, that manipulating that, like, I don't think I can make that happen. So instead, we just let u equal cosine t, right? So then du is negative sine t dt, right here. Derivative of cosine is negative sine, right, from my little chart right up here. So I have the sine t. I don't have the negative sine. All right, think of it as a -1, so we'll balance with a negative on the in, a negative on the out. So then what do I have? I have negative integral. I'm going to use, I've got a u to the fourth in the bottom and a du on top. We can do that, right? So we can rewrite that as negative integral u to the -4 du, power rule, negative u to the -3rd over -3, right? Add 1, divide by the new. Back to t's, and let's see, what can we tidy up to get rid of our negatives? I've got a 1/3. I'm going to go ahead and move that back down to the bottom. Cosine cubed t, right? U to the -3 comes down, u to the +3, and u is cosine t, and remember the 3 goes on the inside. Plus c. Awesome. Last one. E to the 4x minus 1 dx, right? U is going to be, right, the exponent, 4x minus 1. I guess I was in a 4 frame of mind when I made these. So du dx is 4. Du is 4 dx. I don't have the 4. Put it in side. 1/4 to balance. So we're integrating 1/4 e to the u du. Remember, integrating e to the u is just another e to the u. So 1/4 e to the u. Back to x's. 1/4 e to the 4x minus 1 plus c. Okay, so those are u subs.